Okay, let's see. What's the next topic? The next topic is using simplifying complex fractions by using method 2. Using method 2 is by multiplying the numerator and the denominator by the LCD. Okay, so notice we used LCDs in the previous method, in method 1, but what's the difference? Okay, in this case, we are not going to simplify fractions, right? Separate, like just the same way we did, and then by simplifying numerator first and then denominator afterwards. So this is what we're going to do. We are going to find the LCD, but in this case, I would like to give it a different name. So I would like to call this the global LCD. Okay. What do we mean by the global LCD? So the LCD in this case will come from all the denominators inside the huge looking complex fraction. Okay, let's see. Let's highlight all the denominators. I'm going to use a highlighter here. So we have one fraction, another fraction, another fraction, and another fractions. Essentially 4 different fractions, right? Okay, I'm going to highlight. Oops, that's too big. Let's see if I can make it smaller. Maybe like this. No, that's still too big. Let's see. Still too big. One more. Okay, maybe this. Okay. So this is one denominator, right? There's another denominator and then the denominators, right? So highlight or circle whatever you feel more comfortable with. All the denominators of every single simple fraction contained inside of the huge complex fraction. All right. We're going to find the LCD just the same way as if we had a list of fractions, a list of rational expressions. And well, it turns out that we have factors of x and y. But again, for the LCD, we need to compare all the different factors and take the highest power of each. So let's go in alphabetic order. Notice for the x, we have x squared here and we have x to the first power, right? Notice that there is an invisible one. So the highest power of each, and for the highest power of x in this case is 2, all right? And likewise for y, we have y to the first power here and y to the second power on the first fraction. So the highest power of each, the highest power of y rather is x squared, y squared, right? So what are we going to do? We are going to multiply and divide by the global LCD, right? But the overall LCD, x squared, y squared, x squared, y squared, all right? Now, the tricky part here when we distribute, right? When we distribute, notice this x squared times y squared is the product of some integers, right? Essentially what we're doing here is multiplying an integer by a fraction. One thing to keep in mind, okay, let me take this a little bit to the side. Let me give you a simple example. So suppose we want to multiply the number 3 by 1/5, right? The question is, what does the number 3 multiply to in the fraction? Does the 3 multiply the 1? Does the 3 multiply the 5? Does the 3 multiply both? Or it doesn't matter, right? This is what I would ask everybody if we were in lecture in the class, right? However, well, due to our limitations, so I'm just going to take it here to this side and try to explain what do we do. So it turns out that this integer right here multiplies with the numerator of the fraction, right? Why would it multiply only with the numerator? Okay, there is a reason behind, right? Keep up this 3 as having an invisible 1 in the denominator. So when we multiply fractions together, we multiply numbers across. In other words, 3 times 1, which is 3, and 1 times 5, which is 5, right? How are we going to apply this to that ugly looking expression we have over here? Well, let's see. Let's take this back. Okay, so what I'm going to do here is I'm going to distribute the x squared y squared with the first fraction and the x squared y squared with the second fraction. When we do that, okay, we are going to multiply this x squared y squared only with the numerator of this mini fraction right here, just the same way as we did it on the side screen, right? With the numbers, with the 3 times a fifth. Okay, so let's see how that looks like. So I'm gonna write x, right? And in this case, I'm gonna keep the same colors just so you can see where is this x squared y squared comes from. This x squared y squared comes from distributing and multiplying with x. And I'm keeping the same colors, guys, just to keep this color coded and so you don't get lost. Okay, divided by y squared. All right. Okay, plus. Okay, I'm going to distribute and I'm going to multiply 1. I know we may not need to write that 1, but for visual purposes, I'm going to keep it, and I'm going to x squared y squared. Okay, and then this gets divided by the quantity y. Okay, this came out a little ugly here. Okay, let's write it. Let's write this better. Okay, y squared. And let's divide the whole thing by whatever we get from doing the exact same we did for the numerator. But now, okay, we are going to multiply x squared y squared with the numerator only of this first fraction in the denominator, and I'm going to do the same with the numerator of the second fraction. So in other words, this y multiplies the quantity x squared y squared, and then I'm going to divide by the quantity x squared that is highlighted here. Okay. Well, you may be thinking, well, it doesn't seem to simplify the entire expression. I agree, right? In fact, it seemed to make it even uglier, right? But after we're done with the distribution here, you will see the power of method 2. You will see how I personally prefer method 2, right? Because it's quicker, it's faster rather than taking 2 separate problems and then putting everything together. So we're gonna write, I'll show you the difference in a couple minutes or so. Okay, multiply with x squared y squared, and let's divide this by just x. All right, yes, this kind of ugly expression turned into something even uglier. Okay, but at this point we are going to look at each fraction. This fraction right here, this fraction right there, this fraction right here, and this fraction right there. One at a time. We are going to divide out common factors at every single every single simpler fraction inside of the big fraction, right? And let's see. Notice we can divide out. Let's see. Let me change the color. Okay. We can cancel out this y squared with this y squared, right? We can divide out this y squared by y, leaving us with a 1 here, a power 1 essentially. On this third fraction right here, we can divide out x squared with x squared, and the same as we did at the top, we can divide out the power 2 with x, leaving us with a power 1. Now, what are we going to be left with? Okay. Notice we are going to have the quantity x times x squared. If when we multiply the two quantities together, we basically add the exponent. So x times x squared is going to give us x cubed. Plus 1 times x squared, that's just going to be x squared, right? Notice I'm not writing any denominators here, right? Because this denominator in each individual fraction, they're gone. Okay, let's simplify. Let's go ahead and simplify the second part, the denominator. So we have y times y squared, which is going to give us y cubed. And 1 times, looks like I was missing x squared y here. And then, I was missing a y here, so go ahead and go back to this second term in the numerator and add this y to the first. And we're going to be left with 1 times xy squared. xy squared. Okay, so what did we do now? So we turn a huge, ugly looking complex fraction and we turn it into a simpler fraction, right? By multiplying numerator by a global LCD, right? And at this point, let's see if we can simplify this a bit further, okay? Let's scroll this down. So, and here is where again we are going to use we're going to use all the toolkit that we got into when in chapter 5, which is all the factoring techniques. So let's see. Let's look at the numerator of this preliminary result. Notice we have a GCF of x squared, leaving us with x plus y, right? And the denominator, we can factor out a y squared, and we are left with y plus x. Okay, but hey, wait a minute. This y plus x is exactly the same as saying x plus y, right? Because when it comes to adding fractions, adding numbers, order doesn't matter for addition, but it does for the difference, for subtraction, right? And from here, we can divide out this x plus y with that x plus y, leaving us with, as final answer, x squared divided by y squared. Okay. Not surprisingly, the same result we got by simplifying this expression using method 1. Let's go back. I'm going to scroll a little bit back to method 1, in which we simplify this problem using the same thing, using a different technique, but we got the same results. Okay, let's compare 2 different methods, the same result. All right. Okay, let's see. Let's move on to another example. Okay, let's look at letter B. Okay, letter B using method 2. Yes, the expression looks ugly. Yes, I'm not gonna lie, it looks ugly. However, let's first look for the LCD. Okay, the LCD, we get that by looking at each different denominator. Actually, I'm going to highlight using different colors instead. Okay, so I'm going to highlight x plus 3. Okay, x plus 3, with x plus 3 is one of the different factors, and on the other hand, we have x minus 1 and x minus 1. So the LCD will be the product of the 2 different denominators in this case, and we take again the highest power of each, right? However, in this case, notice there are no parentheses around any of the denominators. When there's no parentheses around and it's by itself, we can think of them as having this to the first power, but we don't need to do that, right? It could be understood that this is to the first power, so the LCD will be the product x plus 3 times the quantity x minus 1. Okay, so that'll be our LCD. So let's go ahead and multiply numerator and denominator by the LCD, which is this quantity x plus 3 times x minus 1. Okay, how are we going to simplify this? Okay, we are going to do number one. Distribute the product of these two factors first over the first term, but when we do that, notice the first term has a numerator and a denominator. Again, when we multiply a quantity by a fraction, the quantity multiplies with the numerator only. And again, I'm going to make this be reflected using the same colors, right? Using, rather different colors. The 3 and the x plus 3, I'm going to keep them in blue. And the number we're distributing, or the quantity we're distributing, in this case, x plus 3, x minus 1 in orange, just so you can see where it is coming from, right? So, let's divide this by x plus 3. Okay, at this point we could divide out these x plus 3's, right, and see the magic of finding an overall LCD that kills off every single denominator in one shot, basically, rather than writing two separate problems, numerator, denominator. But I'm going to save this until the end, when we're done distributing with all fractions inside this complex fraction, and then plus 4 times the quantity x plus 3 times x minus 1. And let's divide this by what we had in green right here, x minus 1. Okay. Now we're done with the first part, the numerator. Now let's do the same. Multiply, distribute with the first term in the denominator. All right, so that's going to be 2 times x plus 3 times x minus 1. Okay, let's divide that by the quantity x plus 3, right? And then do the operation implied. In this case, it's minus. Oh, that's a very large minus sign. And 5 times x plus 3 times x minus 1. And then divide that by the denominator that this came from it, which is x minus 1. Okay. So at this point, we are ready to divide out any common factors. Okay. So let's use a different color to cancel x plus 3 with x plus 3 here, x minus 1 with x minus 1, x plus 3 with x plus 3, x minus 1 with x minus 1. On the next step, what are we going to be left with? So for the first fraction, we're left with the quantity 3 times x minus 1. Okay, so 3 times x minus 1. I know what you're thinking. You might want to distribute this right off the bat, but no, don't do that. Because especially for the denominator part, if you try to do that, that's a lot of room for silly mistakes or silly sign mistakes, and you don't want to have that. So 4 times the quantity x plus 3. Okay, and then divide that by 2 times x minus 1. Okay, in this case, minus the quantity 5 times x plus 3. Okay. At this point, we are good to go and use the distributive property, right? And simplify this expression. So what are we going to have? Oops. We're going to have the following. So for the numerator, we're going to have the quantity 3 times x, which is oh, come on. Which is 3x. 3 times negative 1, which is negative 3, plus 4 times x, which is 4x, plus 4 times 3, which is 12. Divide that by the quantity 2 times x, 2 times negative 1. 2x minus 2, that is going to give us 2x minus 2. And be careful here. Be careful here because we're going to have a combination of signs, right? Negative 5 times x and negative 5 times positive 3. All right? So that's going to give us negative 5x minus 15. So let's combine like terms in the numerator, combine like terms in the denominator, and we would be essentially done with this exercise. So in the numerator, we have a 3x plus 4x giving us a 7x, right? If you want to highlight this, x's with x's and numbers with numbers, right? X's with x's, number with numbers. So negative 3 plus 12, that's going to give us a negative 9 divided by, okay, let's again highlight x's with x's, which is going to give us 2x minus 5x, that's going to give us negative 3x, and finally negative 2 and negative 15, that will give us negative 17. Okay, let's observe this final result right here. The following step would be to try and factor anything out in the numerator and the denominator. However, there is no GCF in the numerator, there is no GCF in the denominator, there's nothing to divide out. Therefore, we call it a day for this exercise. All right. Okay. Let's look at another example. Okay, a very typical example, right? This doesn't look like a complex fraction, right? This doesn't look like having a big fraction with many fractions inside. Okay, in this case, we have negative exponents, right? So in this case, this is where we need to recall what negative exponents mean. For example, every time we have the quantity x to negative a, any number, right, to a negative power, this is the same as writing this as 1 over x raised to the a power with positive sign, right? So we are going to write all these negative powers, right, with positive exponents using fractions for each, right? So x to the negative 1 would be the same as saying 1 over x, right? Plus 2 times x minus 2. Okay, I need to make a point here, a very important point. Okay, note. I'm going to use the space above to explain this very, very important note. Notice this 2x in the denominator, 2x to the negative 1 in the first term of the denominator, and notice this 2x, the whole thing to the negative 1 in the denominator, right? In the first case, right, 2x to the negative 1, right? Let's write a note. This will be the same as saying 2 divided by x, right? In this case, the note is the negative exponent only affects the variable. Right? Whilst on the second case, 2x, the whole thing to the negative 1. Notice in this case, the quantity, it is the entire quantity 2x, right, inside of the parentheses, right? So this will be 1 divided by 2x, right? Because in this case, the negative exponent affects both factors that lie inside of the parentheses. Oops. All right. Okay, let me make me some space here. Let me just move this a little bit higher so I have enough space to simplify the example. All right. So in this case, we are going to have the quantity 2. Okay, let's see. All right. 2 divided by, oh, come on. Okay, looks like I'm having a little bit of trouble here with blue. Okay, let's see if that works. Okay, no, it's not letting me do that. Okay, 2 divided by x squared. And then the whole thing divided by, in this case, okay, let's use what we have on the notes here, right? 2 divided by x and 1 divided by 2x, okay? All right, the next step will be to find what the LCD is. Okay, let's multiply by whatever the LCD is here. And notice in this case, the LCD will be, okay, let's keep it like this. The LCD will be the product of the different factors. In this case, we have x, right? And the highest power that we see of x is the number 2, x to the second power. However, another factor that shows up in at least one denominator is the number 2, okay? So 2x squared will be the least common denominator. So we're going to multiply numerator and denominator by 2x squared. All right, so let's do the same we did before. Let's distribute and distribute. Okay, so we're going to get the following. 2x, keeping actually the same. So 1 times 2x squared, that's going to give us 1 times 2x squared divided by x plus 2 times the quantity that we distribute from the outside, which is 2x squared, and then divide that by x squared. And we're going to divide this by whatever we get from distributing here, which in this case, multiply with the numerator, multiply with the numerator. All right, so 2 divided by x, well, times the quantity 2x squared, and plus 1 that multiplies the quantity 2x squared over the quantity 2x. Okay, now at this point, let's observe each individual fraction and see what can we divide out as common factors. So notice 1 power of x divides out x, leaving us with 1 power. Here we can cancel out x squared with x squared. Same here, we can divide out 1 power of x, leaving us with a 1 power. And here we can divide out x, the number 2 rather, and 1 power of x, leaving us with 1. Now, let's see what do we get at each of the denominator of each of the fractions rather. So in the first term of the numerator, we are left with 1 times 2, which is 2. As far as variables, we were left with 1 power of x, which is just x, plus 2 that multiplies 2, which is going to be 4. And no variables appear because both x squared and x squared got canceled. over here we multiply 2 times 2, which is 4, times the quantity x to the first power, which is just x. And in this case, we were left with the quantity 1 times x to the first power. The 2's and 1 power of x got canceled. So this simplifies to 2x plus 4, which is still the same, 2x plus 4. And then divide that by whatever we get from combining these two terms, which is 5x. And in this case, there is nothing to divide out. So even though you might want to go the extra mile, maybe, why not? 2 times x plus 2, no big deal. However, there will be still nothing we can divide out, okay? So that was another example of simplifying complex fractions in which we use the second method by multiplying by an overall method, right? I mean an overall LCD that comes from looking at all the denominators in this case, right? Instead of working with the numerator first, simplify, and then denominator afterwards, then simplify, okay? Let's go ahead and do another example. Letter D. Okay, letter D, yes, looks big, all right. Okay, let's look at one at a time. So the numerator has two terms in simpler form. There's nothing we can factor out. However, the denominator has a polynomial, right? So in that case, you might want to write the polynomial in factor form, right? So x plus 2 under 2 and x plus 7 under 6. The whole thing divided by 4x plus 13. And we are going to factor this trinomial in the denominator of the big fraction. And notice we have a trinomial with a leading coefficient of 1. In this case, we use the double bubble method, right? And this works by looking for factors of 14 that add up to 9. In this case, this will be 5 and 4, maybe. No, that's going to give us a 20. No, not 5 and 4. How about 2 times 7? 2 times 7 equals 14. 2 plus 7 equals 9, right? Good. The next step, find the LCD. Find a global LCD, right? Find the LCD of all fractions, of all denominators that you see contained in the complex fraction. So LCD. LCD will be the product of x plus 2, x plus 7, and well, x plus 2, x plus 7 is there. So no need to write anything else. The highest instant, the highest power of each factor is 1 again. So x plus 2 times x plus 7 divided by the same quantity, x plus 2 times x plus 7. All right. Okay, let's do the distribution. Yes, this will take us a little bit of writing, right? But hopefully by now, by looking at example, you see the whole gist of this method is to use the distributive property and divide out common factors as we go, right? So, okay, again, I'm going to keep the same color coding, right? 2 times the quantity x plus 2 times x minus 7 plus, divided by x plus 2 plus the quantity 2 times x plus 2, x not minus 7, rather this is a plus 7, x plus 7, and divided by the quantity x plus 7. Okay, let's divide the whole thing by whatever we get from distributing the LCD with this. And keep in mind, for x plus 13, you might want to put invisible, those implied or invisible parentheses, so we don't get freaked out about it. Okay, I'm gonna keep the same color coding. Okay, so in this case, 4x plus 13, that multiplies the quantity x plus 2 times x plus 7. That gets divided by the quantity, the product of these two, which is the LCD itself. X plus 2, x plus 7. All right, so we multiply numerator and denominator by the LCD. Now, let's divide out common factors for each denominator, for each term in the numerator and the denominator. So, in the numerator, on the first fraction, notice we can divide out an x plus 2. In the second term, we can divide out an x plus 7 with x plus 7. And the most interesting part right here in the denominator, x plus 2 goes away with x plus 2, x plus 7 with x plus 7. The whole thing goes away here. So what are we going to be left with? The following. In the numerator, again, you don't want to do this distributing in your head at the same time. Do one step at a time. 2 times x plus 7 plus 2 times x plus 2, right? And that gets divided by the quantity only as whole for x plus 13. Nothing else survives in the denominator other than the 4x plus 13. So the next step, distribute the 2 over the first set of parentheses and do the same for second term, leaving us with 2x plus 14, careful, 2 times 7 is 14, plus 2 times x, which is 2x, plus 2 times 2, which is 4. And that gets divided by 4x plus 13. Now let's simplify, let's combine like terms in the numerator. X's with x's, 2x plus 2x, and numbers with numbers, giving us 2x plus 2x, which is 4x, and 14 plus 4, which is 18, right? And 4x plus 13 is simply 4x plus 13, all right? Well, is there anything we can do to factor this out? Well, in the numerator, you might want to factor a 2, but that is not going to be any useful at all, because in the denominator we cannot factor anything out. Notice the number 4 and the number 13, they don't have anything in common, so we can just call it a day for this example right here. And again, this 4x cannot be canceled. Remember, a kitty dies every time you cancel terms. We don't cancel terms, right? We only cancel common factors, right? Two different things. Again, let's keep that in mind every time you are working with rational expressions, right? Okay, let's see what's next. We have one more. I think it's only one more to go. All right, let's look at letter E. For letter E, we have this term, right? In the denominator with the x plus 3 with a negative power. That is the same as saying 4 divided by 3 plus 1 over x plus 3, right? Now, how do we simplify that? How? In this case, this one is a little bit weird to even look at. So let's make this look a little bit nicer. Okay, this number 4, which is a very nice integer, this is the same as saying 4 over an invisible 1. And then let's divide that by the number 3 that we have here and divide it by an invisible 1, right? Plus 1 divided by x plus 3, okay? So now this looks like complex fraction. Fractions contained inside a big, huge fraction here. Okay, let's see. Let's find the LCD. Oh, this is not equal sign yet. At this point, let's brackets, multiply by the LCD. The LCD will be the product of 1 times x plus 3, right? Or simply the quantity x plus 3. No need to write that one, right? So x plus 3 in the numerator, x plus 3 in the denominator. So let's see. Let's do the distribution part. Multiply x plus 3 times 4 only, not the 1. X plus 3 times 3 and x plus 3 times 1. Okay, so that's the plan. Okay, that's how we're going to distribute this. Okay, so let me go down here maybe. Yes, over here is fine. 4 times the quantity x plus 3. All right, and that gets divided by the invisible 1. Yes, you might want to still write that invisible 1 just so you know where is everything coming from, right? So let me actually give some space here. Let me erase the whole thing right here. Let me do the 4 times x plus 3 times, divided by the invisible 1. This invisible 1 right here. And then, well, we're essentially done distributing with the numerator. Let's go ahead and do it with the denominator. 3 times x plus 3 divided by 1, and the quantity x plus 3 times 1, right? That's 1 times x plus 3 divided by the quantity x plus 3. Okay, let me change this denominator right here with a green positive 1, right, which was the invisible positive 1, right? Okay, at this point, let's simplify, or rather divide out common factors. Okay, 4 divided by 1 is simply 4 that multiplies x plus 3. Divide that by the quantity 3 over 1, which is just 3, that multiplies x plus 3. Plus the quantity x plus 3, notice we can divide it out. X plus 3, x plus 3. Okay, so that'll give us a plus 1. We're ready to simplify this. Distribute the 4 and distribute the 3 here. Okay, so this will be 4x plus 12 divided by 3x plus 9 plus 1. We are essentially done, except that we can still go a bit further by combining this 9 with this 1, which will add up to 3x plus 10 in the denominator and 4x plus 12. Okay, so at this point, you may be thinking, okay, maybe we can factor anything out, of course, right? Maybe you want to factor a 4 and x plus 3. But in the denominator, there is really nothing we can do any further, right? So in this case, either answer is fine. If there is really nothing we can divide out, or if for some reason one of the terms, rather the numerator or the denominator, one of them doesn't have a common factor, you can leave it like this, right? Like the second to the last term, or go ahead and factor whatever you can. Again, in this case, there is no choice. There is a choice to follow what you want to do. Now, The question is, which method am I going to ask you on the exam or the homework? Well, very important note, okay? A very important note. Okay. Both. Well, hold on. Okay. Homework doesn't specify to follow any method. Okay, homework, in the homework, when you go to MyMathLab, the homework questions are just going to be worded like simplify the complex fraction. That is, you follow any method you want. On the exam, good question. On the exam, you choose the method. Right, you pick your poison for the exam, right? You can use either method 1 by simplifying two problems first, two expressions first, then put it together, divide out, or method 2, which is by finding a global LCD, and essentially what we have done here before. Okay, so this is it for section 6.3, simplifying complex fractions, right? Okay, let me give you just a silly example, right, about how can we use complex fractions. So let me give you this problem on the side. This suppose we have, let's say, we have 4. No, not 4. We have 2.5 pizzas. And we divide them in, notice the word I'm going to use here, in fourths. Be careful, right? I'm dividing each pizza in fourths. Not in 4, right? It's a whole different thing. The question is, how many slices do we have? How many slices is that, right? Interesting question. It's making me hungry, by the way, right? So the best thing to do here is draw a picture. Okay, draw a picture. Let's see, pizzas, pizza. Okay, there's one pizza. There is another pizza right here. And then we have half a pizza, not the entire pizza, just half of it. Okay, each pizza is divided in fourths, right? That means 4 slices, right? 1/4, 2/4, 3/4, 4/4. That'll be comprising the entire pizza, right? Then we have another pizza divided in fourths. And well, here I'm not going to divide it in 4 pieces because it's only half of the pizza, right? So if we had basically the other half, we would have 2 more slices. So if we count all the pizza slices right here, we would have a total of 10 slices. All right, that's the answer, 10 slices. All right, but what does that have anything to do with complex fractions? Okay, Can we simplify, can we represent this situation using complex fractions? Of course. Let's have a look. So we have, how do we do that? We have 2.5 pizzas divided in 4s, right? Okay. Let's simplify this complex fraction using any method. I'm going to use method 1. I'm going to use method 1. I'm going to divide this by, let me have an invisible 1, right? Okay, let me actually erase this part right here. Okay, these 2 pizzas, these 2 are divided by 1, missing factor in order to have the same denominator, 2 and 2. So we will essentially have 4 halves plus 1 half. Divide that by 1/4. So we can add the halves in the numerator, 4 plus 1. That will give us 5 halves divided by 1/4. Okay, so what are we doing here? We are dividing fractions, right? In order to divide fractions, keep the first fraction and multiply by the reciprocal of the second fraction. So the reciprocal of 1/4 is the same as 4/1. In this case, what do we have? 5 times 4, that's 20, divided by 2, and surprise, surprise, 10 slices, right? So that, I think this is a very cool and fun application of real life, right? Thinking about pizzas, right? Something I guess we all like, right? Who doesn't like pizza? I guess something we all like. All right. So this is it for section 6.3 complex fractions. On the following video, we are going to work on solving equations that involve rational expressions. Okay, so see you on the next video. Okay.